Hi, so this is the PID controller, which is our experiment number 6. So this is the circuit which we have built, and we have used 5 op-amps. One is the differential, the proportional, derivative, integral, and the summation, which sums up all these things for the final PID. This is the function generator, and this is the power source used for this experiment. Now let us look at the output of the first op-amp, which is the differential. So I'll insert the probe in the output region of the op-amp. Let's say auto set. Let us look what the output is. Alright, so this is a square input, and we are getting the exact inverting output, which was expected because this is an inverting op-amp. Let us look at the output for the sine wave. Alright, so we are getting exact inverting output, and let's look at the triangular wave. Alright, so this looks good. Now let us go for the second op-amp, which is the proportional op-amp. Let me take out the probe from this. Alright, I inserted the probe in the proportional. Let us first look at the sine wave. Look, so the output looks the same as the input. This is because we have used 2 op-amps which are both inverting. The first inverting op-amp, it inverts the output and inverts the input. The second again inverts it, which leads us that the output becomes the same as the input. Now looking at the square wave and the triangular wave. So in all these 3 we find that the input and the output are the same. That was expected. Now let us go for the third one, which is the derivative op-amp. I would say the best way to look at the output of the derivative op-amp can be a square wave. Let us consider the square wave. I'll say auto set. Now this is the input, this is the output. This was expected because we are using a capacitor. So these are the times taken to charge and discharge the capacitor, because of which the output we get happens to be something like this. Alright, now let us go to the integral op-amp. The integral op-amp, yeah, perfect. And now let us look at the output. Considering the square wave as the input, let me auto set it. This output is as expected. This output is as expected. For the square input we are getting a triangular output, and of course by DC offset we can get these things cleared, but that's fine. Now let us go for the final, which is the output of the summation op-amp, which will be a PID controller. Alright, and for this let us increase the frequency. I increase the frequency from 100 Hz to 1000 Hz. Let me have both of them in the same scale. Alright, so this again looks same as the inverting op-amp. So from this we probably conclude that the output of the PID controller is kind of the same as an inverting op-amp. The input and the output voltage is also the same, and fine, this probably leads us to the end of the experiment. Thank you so much. This was the PID controller.